Alright, hello everyone. I realised I should probably stream a little bit today. I've done quite a bit since last night. Today is Wednesday, the 24th of June, and the jam ends in 2 days. And part of that will be like making a build and uploading it to the jam itch page and creating the itch page itself. So I think I want to be done with the game by the end of tomorrow. So there's a lot to do today, and quite a lot of difficult things that I've left for today. Particularly procedurally animate legs, just to sort of bring the game alive, make the character move around properly. That's going to be really tough. I don't know how to do that. Probably just going to follow a tutorial. Get the slot machine animation working. That's what I've been doing today. This is easy, add in the confetti. Our current game name is Chimera Noodle Race. I don't know if we'll stick with it, but we'll see. Design a basic level. That's probably going to happen tomorrow, realistically. And I can do that together with Charlie, my teammate. Add UI for abilities and stats. I briefly mentioned this to Charlie. We talked about it. Oopsie. Where's my... Okay. This is our little draft. So you're playing your game. The UI is just going to be your head, torso, and legs in the corner. And whatever stat changes or abilities that gives you with the relevant key to press for that ability. So that should be fairly simple. And then it's your time in the top middle, and then just below that is the number of checkpoints that you've gone through. We also need to write the checkpoint logic so that you can... it's something you have to pass through, and if you fall off the map or die or something during the race, you'll respawn at the checkpoint. Yes. Oh. This is the same as this. Nice. That's one less thing on the to-do list. We still need to add more sound effects and more animal sounds and whatever. We need to add the music once Charlie's made it. Improve the main menu. It looks a bit, game jammy. But whatever. And then I think we won't get around to this, but basically if you roll snake legs, which don't exist, snake legs are an empty mesh, because snakes don't have legs. What we were saying was whatever combination of animal parts you've made, they should crawl along the ground rather than walk. But that's quite advanced. I don't think I'll get around to that. So anyway... What have I done since the last stream? The main thing is the slot machine stuff. That's what we've done. I'll show you the game so far. Once we can compile it. So I've made a material. It's quite complicated what I've done. I can delete these. Don't need them, I think. I'll delete this one. Don't need this one. This is just a test. Okay. So you've got a render capture for the different body parts. You've got our render targets, which spawns a load of render target blueprints. And each of these has a body part against the white background with a scene capture camera, which will map onto the render target. And then you use these render targets in the material that I've just written. So I wrote a bit of where is it? I wrote a bit of HLSL. Where is it? Material or slot spinner. There we go. So I wrote a bit of code which I'll talk through briefly, but it's not the code that I wanted to write, basically. So the idea is that you'd be able to make a material for the slot spinner, which looks like this. It's just this semicircle mesh. And then this would go into the slot machine, and you'd see like a bunch of pictures scrolling past really fast, and it would stop on a certain picture. Now, the idea that I had is that this is just a material that scrolls. And there's certain ways to make things scroll in materials already. There's this panner node, which, as long as you're only scrolling vertically with the V out of UV, it will scroll in the Y direction over time. You can change the speed using a parameter. And I did do this. Can I show this? Okay, yeah. If I plug this into the scroll offset, it basically does this. Alright, it scrolls through at a certain speed, and you can change that speed to whatever you want. So I've just doubled it, and once it loads, you can see it's going faster. If I make that 10 to be really fast, which is probably what I will set it to, because reels do spin really fast. Yeah, that's the reel spinning. And the way that I've done this effect is these are just sort of like a bunch of test textures, just so I can see that it's all working. These are all input parameters. So in blueprints, you'll make a dynamic material instance and set that on your spinner mesh. And then you'll set each of these textures to be your render target of the different body parts that you're going to spin between. And then all of these get used in the bit of code that I wrote. So it's a custom node in the material graph, and I've made it sort of customizable, so you can have any number up to 12 different textures to scroll between, because there are 12 zodiac animals, so we're just going with 12 as the max for now. So from 0 to 11. This could just be an else rather than else if, but whatever. Never mind. So yeah, it gets your count. Make sure it's at least 1. So it doesn't break. And then you'll basically find the pixel on the film strip. On this virtual, we're building a virtual film strip that is basically like all of these textures attached to each other in code. And then we'll do a bit of maths to find out which texture we have to display and exactly what part of the texture to display based off our virtual film strip pixel. And so it does this, uses the textures that you've input, depending on what slot you've calculated. And the idea is, in blueprints, you control how fast it spins by increasing this scroll offset parameter over time. And then once you pick a slot, you stop making it the scroll offset change over time, and instead you set it to whatever the scroll offset should be for that given picture. So that's the idea. So I was quite happy with this. I'm quite happy that it works as I expected it to. Because I didn't expect it to work. First time I thought I'd run into problems. And I'll talk a little bit about what I wanted to write, because it's not my ideal material graph for this. Ideally, you don't pass in individual 12 textures, right? That's crazy. What I'd want to do is pass in an array of textures, and then this would accept that array, and it would just have a for loop rather than all this else if code. All of this is like really bad code principles, but I couldn't work out in a custom material graph how to get an array of textures. That's the problem. If my input parameters could be of type array, texture array, then this would be so much simpler. But nevertheless, I don't think we'll ever want more than 12, and I've already written the code, so whatever. I don't mind. It's okay. Maybe they'll change that in Unreal Engine 6, but yeah, we'll see. So the thing that I'm doing now is plugging all of that logic in to the spinner, slot spinner, what do you call it? Mesh, actor class, blueprint class. So we have our slot spinner material, and in our event begin play, we'll set the we'll create a dynamic material and set all of those textures onto it. And you can see I've just written this code, so you'll get the render targets actor blueprint class. You'll spawn that in. And basically what that does is it spawns in, if I press play, sorry, let me fix this first. Make sure it compiles properly. What was it that wasn't compiling? Slot machine wasn't compiling. Yes, of course. BP spinner. BP slot spinner. Right, I'll just do that and carry on. So you can see this is the main menu level. You can see there's a render targets BP that spawns in all of these individual render target blueprints, and what each of these does. I mean, we are lagging a little bit. It might not be very performant, is the problem. It's spawned in all of these different body parts individually, and there's a render target camera capturing each of these and making a render target picture out of it. Now maybe I can make the pictures less detailed. Maybe that's what's difficult, because every frame, every single one of those 36 cameras is rendering the image in front of it. If I, and at the moment it's set to 1024 by 1024, I'm going to reduce that by a quarter, or I guess 16, because it's quarter times a quarter. I'm going to reduce it to 256 by 256. So in our render target blueprint, I'm going to get the scene, capture component. Do you set it on here, or do you set it on the texture itself? Texture target is what you need to change it on. And that is set in the targets, I think. So create render target. Let's have a variable on here actually for the size of the image that we create. So yeah, let's promote a variable, image dimensions, and we'll set that to 256. Okay. Maybe that helps it a little bit. If it's possible to make it not every tick that it captures each of the body parts, that'd be nice. Maybe every 5 ticks or something would help. Even just every 36 ticks. You know. So let's, because I mean this is really lagging now. So maybe we don't do this. I'll have to optimize it in some way. Maybe reduce the level of detail or something. Cool. So yeah, this is what we've got. It's a bit serial killer vibe, but these are all the meshes that we've got so far, and they should eventually make up all of the animals that you have in the slot spinner in this thing. So let's go to the slot spinner. So it creates the dynamic material instance and creates an array of either head textures, torso textures, or leg textures, and sets all of those materials on the dynamic material instance, just by doing it by parameter name, and all of the parameters are named text 0 to 11. Let's just double check that is correct because I haven't confirmed that. So slot spinner, yeah, text 0 to, it should be, okay, here we go. It should be 0 to 11. Let's change this. That wouldn't have worked and I would have been very confused. So I have to change them all manually. And again, this is a consequence of not being able to deal with arrays inside a material graph, as far as I know. If anyone knows better, please do tell me. But it means the upkeep is a little bit more difficult. Okay, there we go. Cool. So what we need to do is go to our slot machine. That's what we were working on. And we'll just get back to the center. So our slot machine, and I've only just started to write this before I started stream. So at the moment we've got 3 spinner locations at the correct locations on the slot machine, and we'll spawn in each of our slot spinner actors on begin play. So we'll need to do this 3 times. And we'll set is head spinner to true. And then we'll have our spinner 2 relative location. And again, we'll set is torso spinner to true. Maybe I could have had an enumerator for body part type, head, torso, or legs, but never mind. I've gone with this for now, just simple balls. And then we'll do the same again for spinner 3. Okay. And we don't set anything on that because it's just legs by default. So let's have a look at what that looks like for now. So if we drag in our slot machine actor over here and press play. What's happened there? Oh, okay. I think it's spawned them in not in a relative location, but in the world location. So let's make it a relative location. So in the slot machine blueprint, spawn transform location, and I want to make this relative. So do I have to attach actor to actor? Parent actor is reference to self. And keep snap the target maybe. And the scale. See if this works for one of the spinners. Doesn't seem to, because it's spawning it in and then saying snap to it. So we'd have to set the location when it spawns in to be a world location. which is fine. So BP slot machine, instead of the same relative location, we'll just get world transform, I think. So get world transform, and let's undo this, recombine the struct bin, and just do this. And let's test. Oh, we never actually attached it. We never plugged this in. Never mind. Maybe that would have worked, but I think we'll do it this way instead. For now. Okay, that's good. And I think we'll do a keeper relative on that as well. So we will end up doing this. And we'll say keeper relative. And if I... but now it's doing the thing where it's... okay. Right. Get relative transform. Okay, there we go. Interesting. Let's undo that. And let's just keep world, maybe. Yeah, fine, that'll do. And so then, just to test it out, if I move that spinner, if I move the slot machine, does it move the spinners with it? Let's have a look. So I move this around. It's really lagging for me. I don't know if it's just because I'm streaming. If I change the location of the slot machine, I set it to it can't move. So let's not worry about that for now. Let's assume that it's going to do the right thing. Let's make this into a function, just so it's a bit easier. And I want a variable for each of these, just so we can keep track of them. So let's say BP spinner. Is that not a type? Type actor. Oh, BP slot spinner, that's why. BP slot spinner. Object reference, and we'll say this is the head spinner. And we'll do the same for torso and legs. Oops. Okay, and then once we've spawned it in, we'll set this on it. Okay, cool. So let's just make this easier to read. We'll make a little sequence where we do head first, then torso, then legs for each of the spinners. I can probably refactor this later, but it's a little bit complicated because I'm setting specific variables on it. So I think what I'm going to do is just have a little bit of messy code, and that's fine. Right. And we'll copy the code for attach actor to actor. Let's move all of this across because it's getting a bit cramped. Let's move it down for now. Move this across and attach actor to actor, like so. Parent actor is self. Okay. We can do the same here. And this will go into second part of the sequence. Again, this isn't the best coding principles, but like repeated code like this shouldn't really exist. Give me a second. Okay. And finally, we do all of this again. Oh, we need to set the torso spinner variable as well. So do that here. Oops. And I'll shamelessly copy and paste. Slightly shamefully. And this is our spinner 3 location. And we don't need to do anything here, but we do need to set this as the legs spinner. Right. So, what happens now? Get rid of this. Let's see if this looks correct when we press begin play. Yeah, I can see them all there. Maybe I'll stop making it emissive. I don't like how shiny it is on the material. Oops, it is it. So click out of that, and on the M slot spinner material, we'll just undo the emissive colour. Cool. And actually I'm going to make this the big one instead of this one, because this is just a mesh. A set of meshes, in fact. So let's make this the big one. Not sure how big it needs to be. We can look at the main menu camera actor, pin this, and then adjust this so it's kind of the right size. Yep, I think that's good. That'll do for now. And then when we load in, boom. So we need to do functions for actually spinning the different animals. So we also need to work out how the offsets are going to work in the slot spinner material. Let's have a test. If we set the offset to 1, it should just fully show, I'm hoping, the second image, the second texture that we have. Yeah. Yeah, okay. I'm just thinking, well, we'll see how it looks. It might not be the ideal way of doing it. Yeah, we'll see. We'll see. So initially we can set the offset to be 777, which is horse, also source. So actually in the slot spinner material itself, first of all I'm going to set all the scroll offset will be 7 by default. Yeah, okay, perfect. And then on the slot spinner blueprint, what I'm going to do is create a custom event called spin start or activate all spinners. Activate all spinners. And this will get each of the spinners. Oh, sorry, this is on the spinner itself. Yeah, that's fine, that's fine. So let's say activate spinner is the event. and this will take the material reference, and we can set a dynamic, set a parameter on it. So we're going to set the scalar parameter. Set to scalar parameter value, and this is our scroll offset that we want to change. And actually we're going to do this on tick. So the slot spinner should tick, so tick is enabled. So event tick, we're going to say we're going to have a scrolling speed, which is just a float value, single. And this determines how fast you're scrolling through. So get delta seconds multiplied by the scroll speed, and we'll add that to the offset value, scroll offset. On the material. So we need to get the parameter value. Get parameter value. Get parameter info. Parameter name. What is this? I don't know if this is the right thing to do. I'm going to keep a track of the scroll offset, I think, on each spinner. So let's have our own scroll offset, which we will default to 7. And this is the thing that we're going to change. So we'll add our changes and set it on the scroll offset. And then we'll set this as the scalar parameter on the material. And activate spinner when that's called. All that's going to do is say spin, we'll have a boolean for b spin. And that will be set to off by default, but we'll turn that on. Let's say start spin, and we'll do a stop spin. Okay, and this tick will check, should I be spinning? So we'll get spin. And if so, I will indeed do this. And in the stop spin, what I'm actually going to do is have an input for what the scroll offset should be when you stop it. So it might scroll so fast that you can't really see it at all. And when it stops, it will actually just stop at the one that we want it to stop at, rather than wherever it currently is. So I'll pass in a float with new scroll offset, and we'll actually just set the scroll offset to be whatever we pass in here. So set scroll offset to be this. Brilliant. Okay. So now we need buttons that can do that for us. So on our slot machine, let's have a function, a custom event called spin all. And that'll get our 3 spinners and it will call start spin. Stop. I'll have a custom event called stop. I think we'll do one for each, you know. So we'll say stop head spin. Is that the right way to do it? I think so. We'll have a stop torso spin. We'll have a stop legs spin. Cool. And then for each of these, we will stop spin and pass in whatever we want. And once again, we'll have in fact, here I'm going to say pass in the animal, and we'll do the logic here for which what the scroll offset should be based on the animal enumerator. So this is the new animal, and this is an e-animal enumerator. And what we're going to do is say scroll offset should be whatever the whatever number this is in the data table. So we have an order in the data table of all the different animals. So let's add that data table animals. And this is of type data table. And we can set this to be data table animal meshes. And what we'll do is create a function for get as a pure function called get scroll offset for animal. And maybe this can be on the spinner itself, actually. I think we'll write this logic in here instead. So actually, what we're going to pass into the spinner functions is the animal enumerator and not the scroll offset. Okay, nice. So how do we do this? We'll have a data table. Don't already have it. Yeah. Data table of animals. And this will give data table type. Data table. And this will be set to that. Right. So we'll get our data table. We'll get the row names. Get data table row names. And let's go through all of them and do a for each loop. And whichever one, so you will use the name to read the data table row. So get data table row for this name and break. It's an S animal meshes stroked. If the animal is equal to the animal that we passed in at the start, so get animal. If this is equal, enumerator equal, then we'll break out of the loop. Yeah, we'll actually just return, if true, return and the scroll offset is going to be equal to the array index, I think. Otherwise, return 0. That's fine. Cool. So let's see if that works. So So that's a function on the spinner. So when you stop spin, you do that. And in the slot machine, we can get rid of some of the logic that we started to write and ended up migrating to the spinner. So in the event graph, we pass in our animal, and we can say spinner, stop spin, pass in the animal. Perfect. We'll do the same for the torso and head. Stop, spin. I'll separate these out slightly, a bit too close. We no longer need this data tier of animals on this class. These also need an input of eAnimal. Same with this one. And we copy and paste this and this. Okay. Nice. And again, we'll do a spin function that we just wrote. So, what's it called? It's called something like start spin. Yep. Or start spin for each of these. Okay. And then we want some way of doing this. So I'm going to say on the character, we'll set up a debug. Not on the character. How can I test this? Let's just set up a loop here in begin play. And I'll just have a little function called well, I'll start spin. Let's do a delay node. Let's say delay by 2 seconds. Let's say start spin or spin all. Yeah, spin all. And let's say delay by another let's say 2.5 seconds, and then we'll call stop head spin. This is just to test out. Delay by another 0.75 seconds, and then again. So this is torso spin, and this is legs spin. And I think we randomly choose a different animal. So we'll get our player pawn, yeah. Cast it to a character that we use, spin doing character. Let's get spin manager, and let's get the weighted pool. Can I actually just pick a random animal? I wonder what the functions on spin manager are. there anything? Let's have a look. So now game logic, we've got the spin manager class. I wanted a function that just picks me a random animal from the pool. So let's find where we do that and make it exposed to other blueprints. So spin all, get animal array for slots. Excuse me. Oh, I wrote this in C++. Let's have a look. So, spin manager class, get animal array for slots. Get animal array for slots. Yeah. That's all of the possible animals where the weight output animals, and as long as you have some animals in the weighted map, you get your animals. Okay, so then in blueprints I want a way to find the chosen one. Or just get a random one. Get animal array for slots. Let's try that from the slot machine. So get animal array for slots, and we'll choose the second to last one. So we'll actually just copy the logic from the spin manager, and that's our chosen animal. Let's create a function in here for choose random animal from pool, and this will do, oops, this will do all of this essentially. Choose random animal from pool, and this is a pure function because it's not doing anything, it's not changing anything, just getting a value. And we will return this, which is our random animal. So what we're doing now, we're plugging that into where we need it on the event graph. So random animal, choose random animal from pool, plug that in there, do the same for this, do the same for this. Right, and let's see if this works. Let's just get it to do that infinitely. So return that back to the start. So we'll play. Okay, fine. I should just do this in the background. But something tells me that the spinning function isn't working. I'm going to slightly adjust the light as well in this main menu scene. So the directional light, I actually want it to come around here a little bit. It shines onto the slot machine. so I can see a little better. What I also need to do on the slot machine is create a dynamic material instance for the slot machine itself, so that I can make the light flash on top using the material whilst it's spinning. So what we can do is in the begin play graph. Can you do it in the constructor? Create dynamic material instance for the base. Perfect. And this will be our M slot machine. And what we're going to do is cache this. So, slot machine material ref. And I think every so often, so starting in begin play, let's make another part of the sequence. I think every so often, let's make this into a function, sorry, before I start doing stuff. We'll make this into a little macro, collapse to macro, and we'll call this continuously do random spins. And let's also have a boolean on the slot machine to see if we should do that or not, because this is just a test function. So be randomly spin. Continuously spin. Yeah, fine. I know what that means. I've set it to off by default, but the one on the main menu, we're going to set that to true. And we'll check it here. So if we want to continuously spin, whoopsie daisy, maybe that's a good thing. Move this down here. If we want to continuously spin, do this. Sorry, that's the wrong execution pin. Should be that one. Can I collapse all of these down into a single spawn spinners function? I think I'm going to do that. So collapse function. We can't do that for some reason. Too many input connections in selection. So actually what we can do is this. That's the function. And we'll call that spawn spinners. How much nicer is that? That's so clean. And we can do a sequence here as well. Again, just to neaten things up, make the logic easier. So we'll spawn our spinners, we'll continually spin them if we want to. And actually we'll do that last. Before then, we're going to create a... Oh, no. We don't need to do anything. We've already created the dynamic material instance in the constructor. So we can get rid of this pin. Remove execution pin. Cool. What we're going to do is... Oh, this is what I wanted to do in begin play. We'll create a timer event. Set timer by event, and every, let's say, 0.5 seconds, every 0.25 seconds, I don't know, looping, we will Set timer by event. I think we make a timer reference. Material. Call it material. Call it timer handle. Flashing material. Because this is going to control how often we're checking what to set on the material properties. So this will be a custom event called update flashing light. So every 0.25 seconds this is going to run, and this is going to say get our slot machine material reference and set a parameter value on it, scalar parameter value, I think. Yeah. Set scalar parameter value, and this will be called flash, question mark. Let's just call it flash without the question mark. This is flash. And what we need to do basically is decide whether or not this is 0 or 1, depending on whether each of our 3 spinners are still spinning. I think what we're going to do is make it so that the light is flashing whilst they're spinning. But maybe we'll have different behavior. So let's make this into a function called should light flash. And this is pure, and this will return a boolean called should flash. And what we're going to do is use all 3 of these spinner objects and ask ourselves, are we spinning? So get spin, and if any of them are spinning, then we should flash. Okay, simple enough. And so we're going to say should flash, should light flash, and we'll convert that to the float to put as our scalar parameter on the material. So now we should see continue with your random spins, that feeds back into there. Okay, cool. So hopefully if everything works, it should continually spin every so often. Which it doesn't seem to. I'm not sure why that is. We are doing spin all. Let's do a print string to see if we're coming into this function. So, continuously spinning. It is going into that function. Right, so there's something wrong. So is it the spinner speed that we're getting wrong? Maybe that's the problem. What is our spinner speed? Let's have a look. Slot spinner. Blueprint. Scrolling speed is 0. That won't help. Set it to 10. Scroll offset is 7 by default. And when we spin, yes, we are doing that. That's fine. So is this called from anywhere? That should be being called from our slot spinner, which is, sorry, our slot machine, which is over here. So when we say spin all, they should all start to spin. We'll check if these are valid. They should be. Ah, it's because we've... no, this should work. Should just be called automatically. Spin all. Yep. Let's have a check. There we go. It is spinning at a very low frame rate, but it is spinning. Okay. It's all spinning the same stuff. They're all heads. So something's gone wrong. Okay, fine. I feel like the rendering all of the different meshes is really killing the frame rate. So what I want to do is reduce the amount that it's capturing. So if we go to the event graph, is it possible to change that somehow? So capture scene. Yeah, so we can do that once after a short delay, and it should we should never have to render anything again. Or we could do it on a timer if we wanted our things to blink, but let's do this for now. And we can turn off do it every tick, because that is really expensive. Capture every frame. Do not do that. 36 of these. So we should notice a big performance increase. Yeah, there we go. Immediately it's running fast. We want it to spin the other way. So I'm going to say the speed is minus on the slot spinner. Let's set this to multiply by -1. So I think because the render isn't capturing any longer, it hasn't got the picture that it needs. So what I am going to do is make it capture every so often. Let's say every second. Maybe that'll be fine. So let's do a on the render target. Let's do a timer by event. Let's say our event is capture scene. Okay. We'll do this at the very beginning as well, on begin play. Well, we'll do it after an ever so slight delay. And let's set timer by event. Okay, fine. We'll just do it this way. Set timer by event once. Initial start delay 0, looping. Okay. We don't need to cache the timer for now. That's okay. Every 1 second it should be capturing. It means we get a lag spike every second, guaranteed. That's crazy. Performance immediately tanks every second. It hasn't even fixed the issue. Scroll offset. Do they not handle negatives? Maybe that's the problem. Maybe it doesn't handle negatives. So go to the slot spinner. Let's get rid of this. Remove pen. And instead we'll go to the slot spinner material. And we'll change the scroll offset. How does it deal with it? It adds it to the mesh. What if I did a take instead? Or the virtual, the virtual pixel's still okay. Then we wanted to go the opposite direction. So what if I did a minus there? What would happen? No, doesn't like it. Right, let's have a think. Is it even that? That's the problem. Might not be, you know. If we go to our spinner class, let's add that -1 back in, just so we know we're sort of going in the right direction. I think it's something to do with the render captures not working. So if we go to render target blueprint, every frame it's capturing scene, all of them, all 36. Do it every 10 seconds. And let's do it once at the start as well, because why not? It's working. They're all heads and they don't always finish at the right position. Scroll offset isn't always accurate for some reason. It's nearly there. It is funny. I do like it. I can maybe zoom in the camera even more, you know, in the main menu. And I'll change the main menu layout a little bit, just to make it not interrupt this little bit. I need to animate the lever as well when I do a spinel. Right, BP. I want the main menu widget, which is in UI, main menu, and let's just move this up a little bit. So increase the Y. Oh, Maybe not. That's the size. Decrease the Y position to about there. And the buttons can go about... Why aren't they moving? Position? Why? Hello? Okay. They can go to about there. It's looking pretty good. It's looking a lot better. The flashing light isn't working, as far as I can tell. You can also angle the camera slightly down, maybe. Slightly up. We'll sort that later. Let's sort the flashing light for now. So slot machine, the event graph. Update flashing light gets called once every 0.25 seconds. And we ask whether we should flash the light. And if so, we pass in 1. And flash is the parameter value that we're setting on here. And this is a scalar parameter called flash. I thought that would work. So... what am I doing? Maybe the render target can happen every 20 seconds. Or a random time. If I space them all out with a random time between like 10 and 20 seconds, they'll all be kind of offset from each other and it won't be a huge lag spike. Crazy approach, but it could work. Random float. Random float and range between 15 and 30 seconds. Very nice. So does that mean for 15 seconds we don't have a... That seems good. And I just want to make sure... Why is that first render target always black? Eject out of here. Render target 0 is always black. Really strange. And it really shouldn't be. But maybe we need to add a delay before the first capture. We can try that. So in the slot machine, spinner, render capture, you can add a larger delay. We want to do that. And then where the slot spinner gets the dynamic material, setting the textures there. Would this have a delay more than the other delay? Maybe that's what's doing it. So let's say this is 0.05, this one is 0.01. I hate having to deal with a bunch of delays everywhere. It's not working. And they're all heads. They really shouldn't be. So in our slot machine, when we spawn in each of the spinners, we're saying, bloody hell, we're saying this is a head spinner. Is it too late by then? It is a head spinner. Then it will go into here. It will create the dynamic material too quickly. So let's have a custom event for create dynamic material, or create update material, and that does this. So then from the slot machine we can just call it at the end here, update the material of the spinner. Well, that didn't work. What else can make them all heads? Where are we setting that texture? Oh. We're getting it from the render target. Getting head textures from render target. VP. Render targets. We're setting head textures to be all of the heads somewhere. So in begin play, we set all of the render targets to this. Okay, that seems fine. The question is, why is it only giving us heads? So it is getting the torso mesh and setting that. We can see that in 3D it is working, but there's something maybe messed up with either this array. We can check that array, see what it has. So let's look at our render targets blueprint, wherever that is. And this should have an array of targets, textures. They are fine. Okay, the actual contents of those are fine. Legs are a bit messed up. Yeah, legs are messed up. We need to fix that. The 10th one is black. For some reason, one's black. Will that update after 15 to 30 seconds? Okay. But either way, those are fine. So it's the spinners themselves not getting the correct array of textures. So when we say update material from the slot spinner, slot machine even, when we spawn the spinners, we are setting head spinner and then updating it, which should be fine. That should be fine. Because then if it is a head spinner, it will set the textures to be correct and use those given textures on the material reference. Oh, I need 3 different materials, don't I? No? Do I? It has its own dynamic material. Thought. Yeah, it has its own dynamic material. Maybe the speed should be slightly random. Or slightly increased for each subsequent spinner. Let's set on the material. The speed, scrolling speed is 10. On the slot machine, when we spawn in the spinner, we could say set the speed to be something. Set speed. Set scrolling speed. So this one can be 10. This one could be 12. And this one could be 14. They should go different speeds now. Yeah, there we go. And what I think is happening is we need to stop. We need to set the scroll offset after it stops spinning. So the slot spinner. Close some of these down, it's getting a bit confusing. So on the slot spinner, when we stop spinning, I wonder if we need to set this on the next frame as well. Or every frame, maybe. Set scroll off. Oh, it sets the scroll offset, but it never does the scalar parameter. It always runs through this once more. That's what it's doing wrong, I think. Material reference. Let's see if this makes the stopping more accurate. Oh, not that we can tell. Why are they all black? Try again. Why are they all black? Are they being called? Are they too far away? Slot spinner. Let's have a look. Render target. Is there a culling thing? Camera position 3. Is that actually the correct position? It looks okay. And the scene capture component seems okay. Oh, it's not connected. Oh, yeah, it's not connected. It's just never gonna go to the right location. Nice, glad we solved that. Now we need to figure out why it's going black. We're always capturing. Maybe we don't do the delay the first time. It is flashing. That's good, that's good, that's good. Let's do a lever pulling animation. Frustrating. We'll come back to it. So let's take a little break. So in spin all, we'll start spin for each of these, and we'll say there's a function or a macro for pull lever. And there'll be a timeline in here. Timeline. I cannot do timelines in a macro. Right, let's get rid of that. Let's just do it in here for now, and then we can always collapse it later. So in the event graph, we're going to add a timeline. Called lever rotation. And this is going to be rotating. There's a float track called rotation. And I guess we rotate it from 0 to 90 degrees. So there's going to be some sort of, it's going to take maybe what? 1, 0, 1. Maybe 1.5 seconds. It's going to start off at 0, 0. and then we're going to end at 0, 0. Oh, sorry, it's going to end at 1.50. And then somewhere in between, it's going to go to 90. Huge. How can we increase the scale of this? Make it easier. Maybe I'll just do it going to 1 rather than 90. And we can always multiply it by 90 afterwards. So it goes to 1. Now how do we make this a nice curve? Not that. Can I not undo that? Hello? I have to redo that. So 0, 0. This is 0, 1.5. And this one is 0.7. This is, I don't know, 0.51. Hello! We'll duplicate this if possible. I'll just add another. Put it back here. Should be a fairly sudden. This shouldn't slow down, this curve. Let's add another key point. And I think it just goes like this. Let's see what that looks like. Let's see what that looks like. So in the event graph, we get the output, which is rotation, and we'll multiply this by 90 to get degrees. So multiply by 90. We'll play this from start. And this will set the lever, set rotation, set rotator, set relative rotation, and it'll just be the yaw. Is it the yaw? No, it's the. What direction is this facing? So it will be the pitch that it's changing, I think. So we'll separate these out and change the pitch. Okay. Let's see what that does. Wrong way, but yeah, pretty perfect. So BP slot machine, we'll just make this minus 90. That should work. Okay. It's nearly there. It's going. It's going. We just need to get these render targets working. And if they don't work, I think I'll just give in and do a single UV, a single rendering of each of them. and just have that in the material preset. So once we capture the scene, we need to make sure the slot spinner is updating its material, maybe? Set textures on material. And it gets those textures from render target. Because our render targets is this being updated properly every time it captures. So create render target. Are these render targets updating? They should do. So yeah, we can do that. Get actor of class. If it's valid, set textures on material. Update material textures. That's what this will do. Let's collapse this. But actually, we can do this inside here. Get rid of that dependency. So get actor of class is valid. We carry on. Yep, let's try that. See if it works. Okay. And then we, after we capture in each render target, we can say, we don't want to do that every time. Do we just say every 5 seconds do this? On our slot spinner, we update material. Set timer by event. Which will update material textures. Let's rename this to construct material. The event. And then we'll have another event for update materials textures. That already exists. Update material. And let's say it does this every 5 seconds. Okay. This doesn't need to be an input. Get rid of this. And wherever that's called from, shouldn't have it going in. Overtake material textures. It also does it in here. But we don't need this. Oops, so daisy. Don't need this. Don't need this. Why is it not working? Why is it not working? Oh jeez. Texture. Access on trying to read property material ref. So it doesn't have the material reference when it sets textures on material. Which tells me that something's coming in here way too early. So where do we do that? Where is this called from? Set textures on material. Before we even have the material reference. That's crazy. Update material textures. Before we have the material. Initial delay. I mean, that's been initially delayed, so it's something else that's calling into this update material textures. And it's doing that from the render target, maybe? No. Not being called from anywhere. The material ref is invalid. We should put a check for is valid. And if it is valid, let's change the textures. The textures on material. This is called from here. And this is called from two places. Called from here immediately after we update the material. Maybe this should have a slight delay. Update material textures. It's fine that we tried to do it there, but let's try to do it again after 0.1 seconds delay and every 5 seconds after that. So what's wrong? Let's have a look. Scroll offset is negative. Let's try making that positive just in case. Slot spinner, scroll offset, let's make that ×1. Does that fix it? Let's wait a little bit. No. It's weird that it was working at the start, and now it's not. Done something to change the behavior. Is here. And it does have the correct meshes. It spawned 36 different render targets. The render targets do exist. They're all happy. Maybe they're just too far away. Let's have a look. So if we go back to the spinner now, is it behaving nicely? They're too far away. We need to make sure they're always rendered. the scroll offset always goes back to 0. It's never actually picking. Why is this? The head spinner is set to yes for some reason. It really shouldn't be. Okay, let's go to slot spinner. The default value for is head spinner should be no. And the render target should always be rendered. I'm not sure how to stop it from being called. How to always make sure far away actor is rendered. You need to increase the net call distance squared under the replication tab of the class defaults section. So if we increase the call, increase this, that's already huge. Fine. And maybe let's decrease the distance that it gets spawned away. What if we do initial spawn distance is just a few times less? Does that fix it? Ooh. Why do they not have a background? Oh, it is kind of working. Right. But it's only when I look at it and then come back that it works. So the render targets should be much lower, let's say. So 10,000 away, which means that they spawn. Let's have a look. They spawn over here in the dark. In the dark and the fog. Underneath here. This shouldn't cast a shadow. Let's make sure that persisted. So cast shadow off. So nothing here. I go to the render targets in person to make sure that they are being rendered and look at them all individually. And then return to the spinner. They're mostly fine. But then it's always been set back to 0 slot offset. So let's look at the spinner. Where does it pass in the slot offset? We can put a breakpoint in here and see what it's doing. Let's put a breakpoint. So the animal is a rat. So already by this point, it's 0. Could be coincidence, but I don't think it is. Let's remove the breakpoint and carry on. So we know that the animal being passed in is just the default. Let's go to the slot machine. Animal being passed in here is just the default one. So where we say stop which is in the continuous spin. This random animal is always rat, supposedly. Number of animals. That should be at least 2. Yeah, perfect. That'll be it. Not that we can tell without going to the rendering things. Render, please. Go back. Have a look. Okay, it's stopping at different ones every time now. I think. You can look at the scroll offset and see if it's always set to 0. Please don't be. Ah, it is. It is still misbehaving. Number of animals 3. See if that works. Okay. I mean, is it just failing to cast? Is it even getting in there? Is it getting to this point? Let's print. Oh, there is none of that player character. That's why. Yeah, it's not even coming into this properly. That's why. So we need to have the player character somewhere. Let's do a print string so that doesn't happen again. No player character. No player character spin to win. So can't choose a random weighted animal. So can't choose a random weighted animal for slot machine. So then in our game, main menu level, we can set we can add a little character spin to win from characters. Add this guy and just put him down here and make him not even tick. Doesn't even need to. No gravity. Make it stationary, make it not tick. Static. Cool. So this should be random. Let's look at the scroll offset. No play character, still there. We can just do a get player character. No, get actor of class. BP spin to win. Check if this is valid. And if it's not, we'll say it's not. And finally, check the scroll offset. Yeah, that's random. Hopefully. Okay, 1, 2, 5. Okay. I love it. We can make the start line is valid. And we'll say print string. There is no start line. Okay. And it's just the render targets. I need to increase the orthogonal width of some of these camera views. Let's make sure they are orthogonal. Render target. Mobility of character. Yeah, that's fine. In fact, let's find the character and make it movable, just so it stops complaining. So the render target, we want to make sure this is orthographic. Ortho width, I'm going to bump up to 150 for the head. And for the legs, I'm going to bump up to 200. And then in terms of culling, the render targets should not cull. Cull distance is massive. Never distance cull. Never distance cull. Doesn't help. Never mind. Scroll offset is still slightly weird. And now it's just using the default textures. I wonder if it's just a problem with it being played in the editor rather than in a build. I might do a very quick build. I'll do a quick Google. It's just weird how inconsistently it's working. If I go and look at all of the renders and then go back, it's fine. That's really struggling. So we come over here and look at them all. They are all fine. And they start to appear perfectly. So it is something to do with culling, I think. If I set the distance of all of them to something not as far away. Minus 1,000 maybe? Does that help? Just for the sake of sanity, let's set it to 0. And they still don't work. It's really interesting. And yet as soon as I look at them, they do work. Definitely need to increase the cold distance. Increase the, not cold distance, the orthogonal width. So if I do this, increase the ortho width to 200. And then in the event graph, increase to 250 and 300. Okay, that looks a little bit better. It's still not appearing in the right spot, but I think that's to do with the camera position more than anything. I think I need to move the camera down to be more centered. Yeah. Just to test it out, I'm going to do this. I'm going to set the render capture to capture on every frame just to see if that fixes the issue that we have. It does, it does, it does. It's something to do with the frequency of capturing. Okay. Whether it persists the state even if B capture every frame is false. Allows velocities motion blur to be computed. Capture priority. Why? Max view distance override. Overwrite. Render scene capture as additional render passes of the main renderer rather than as independent renderers. Applies to scene depth, device depth, base color, blah blah blah. Maybe we end up enabling that. Oh, they're just fixed. That seems really smooth. I don't know really what I did differently. Okay, it seems fine. I'm going to increase the ortho width for the legs because they come up a bit big. Maybe decrease the ortho width for the head. It was a bit small. So, render target for camera 1. The ortho depth should be ortho width, 150. The event graph, it should be 300 for the legs. Right, I'm going to take a break because this seems to be working now. Nice. I'm happy with that. Next up is procedurally animating the legs of the character. I might not stream that because it's going to be a lot of trial and error. Yeah, I don't know what I'm doing with it. So, yeah, cool. I'll end there. Thanks for watching, if you did watch. It was a slightly more painful process than I expected. 2 hours just to tie all the code together. Yeah, not great. But yeah, okay. I'll see you probably tomorrow.